Hello, my name's David Ischak. I'm a technical trainer for Vokèra boilers. We're here at our London Colney showrooms. In this short video, I would like to demonstrate how easy it is to adjust the pump duty cycle on our Vokèra Synergy boilers. The circulators in our Vokèra Synergy boilers are very powerful. They will move more than enough water around the system, overcoming the system's resistance to flow. It's an advantage if we can tune the circulator performance to the requirements of the system. This is adjusting the pump duty cycle. I'll now demonstrate how to adjust the pump duty cycle. The powerful pump in the Vokèra Synergy is adjustable. As sent out from the factory, it's set at around 85% of its power. It can be adjusted between 41% and 100%. To adjust the pump duty cycle, we need to enter installer parameters. First, I'll wake the display up with a press on any button. Then press the menu button for 2 seconds. User parameters. I need to go deeper, so I press the menu button for a further 2 seconds. Password is requested. The password is 18. Use the buttons on the right to select 18. Press top left to enter. Now we need parameter set 4, so use the buttons on the right to select parameter set 4. We need parameter 405, pump control. Type. Press top left to enter. By default, the boiler is set at around 85%. If you're happy with that, leave it, but if you need to increase or decrease down to 41%, that's perfectly possible. I'll set it back to the default setting. When you've made your adjustment, a press on the menu button will lock that change into the settings. Use the bottom left button to return to the main display. There's a pump graph at the beginning of the boiler manual. You can use that to work out the flow rate and head of the circulator at any particular setting. To calculate the flow rate of a central heating system, we need the total heating loss of the property. In the following example, we'll use 9 kilowatts. We'll also need the specific heat capacity of water, which is around 4.2, and this figure is joules per kilogram degrees centigrade. The desired temperature difference across the central heating flow and returns in the following example will be assumed to be 15 degrees centigrade. Multiply 4.2, the specific heat capacity, by 15 degrees centigrade, the temperature difference across the system. That will give us a figure of 63. Now we divide 9 kilowatts by 63, which will give us a flow rate in litres per second of 0.142 litres. Multiply 0.142 litres a second by 3,600 will give us litres per hour, and that total will be 514 in this example. A typical head loss around a domestic heating system can be 2 meters or less. Now we can use those figures on our pump duty graph. This on the x-axis is litres per hour. On the y-axis we have the residual head, the amount of power or head of water the pump can produce at a certain flow rate. For example, if we needed a flow rate of 500 litres an hour and the system had a head loss, a resistance to flow of 2 meters, the point would be here. Now the default setting for our pump is 85, which means the pump will follow that curve. If it only has to overcome 2 meters head of resistance, it means it will deliver over 1,000 litres an hour when we only require 500. So reducing the default setting of 85 towards the minimum setting of 41, I would suggest perhaps 60 would provide enough head and enough flow rate without over pumping the flow around the system. I hope this information has been useful. Thank you very much.